All right, and then I got 24.5, and then I'm going to go south, and of course we're not to scale or anything, but we're going to go south to 19.7. All right, so I know this, I know that, I want to know, I don't know what I want to know. Okay, we'll start with, let's figure out what that length is. That's what we're going to do. We're going to figure out that guy. So I need to know this angle. If this is 135, then that's what's 180 from 135? 180 minus 135. 45. So this is 45 on this side, and this is 45 on that side. Opposite interior angles are equal. This is 45 on this side, so 45 and 75 is 120. So I got 120 over here. Now I can use the law of sines and say the green guy is equal to the square root of, and I'm going to run out of room, 24.5 squared plus 15.3 squared minus 2 times 24.5 times 15.3 cosine 120. Okay, and all that's under the square root thing. Okay, so second function, square root, 24.5, I have no idea, squared, plus 15.3 squared, minus 2. I was told that I write too big, minus 24.5 times, that's 15.3, but you knew that, cosine 120. Okay, so this green side is 34.7. 34 point, we'll make it 8. All right, so I know the green side. Did that help me any?
No.
That was totally useless. How come I calculated that for? I could calculate it, so that's what I calculated it for. Okay. Why don't we calculate, if we calculated that angle, would that make any difference? Okay, if I had a construction line coming this way to here, like that,
Yeah.
now I know absolutely nothing. I think it's time to
Finish it.
Correct.
okay, I need an angle. Okay, what we're going to do, we're going to calculate this angle.
So you said it was 45 already.
No, it's not. That's the angle to the black guy, not to the green guy. Okay, so we're going to calculate the angle to the green guy. Okay, law of sine says 24.5 sine theta is equal to 34.8 sine 120. Okay, so this theta sitting right there, theta is arc sine of the guy over there. So I'm going to cross multiply 24.5 divided by 34.8 times the sine of 120 equals arc sine of the answer. 37.6. So theta, 37.6 degrees. So I know this angle, 37.6. Okay, so I know that angle. I know this side.
What do you multiply on that one?
What? Who?
What you did for getting 37.6?
I cross multiplied and take the arc sine of it.
Oh,
You want me to fill it in?
oh, that'd be wonderful.
Oh, I don't believe it.
37.6.
So 24.5 sine 120 divided by 34.8. Okay, now I know that. I know this. It'd be nice to know this angle up here. How am I going to get that angle?
How are you gonna do that?
Now my drawing is so messed up that I can't see what I'm doing. And, okay, wait a minute. This guy's due south, right? So this is a right angle. If that's a right angle and this is 75 degrees, that means this has to be 15, right? 15 on this side. All right, 15 on this side. If I knew the whole angle here, then, which I do know the whole angle. So if I go 180 minus 37.6 minus 75 minus 45 minus 15, I end up with 7.4 degrees. So I got 7.4 degrees sitting right here. Okay, now I know that angle, this angle, that side. Now I can get the other side, law of sine. So what I'm looking for, A divided by, wait a minute. Yeah, A, but I don't want that angle. No, I'm not done yet. No, not yet. Okay, so I have that angle. I know that this is a right angle. I know that this is coming straight down. I want to find that length. Okay, this guy's coming straight down and is a right angle right there. So this triangle is a right angle. Therefore, I already know its length though. I don't know where it's going. It's cut down here someplace. Okay, it's cutting across someplace here. I don't know where, but I know it's a right angle. I don't know. I do know this angle, and I do know that angle. No, I don't. Yes, I do. No, I don't. If this is a right angle, and that's 7.4, then that other angle, 90 minus 7.4, 82.6. This is going to be 82.6. 82.6 degrees. All right. Okay. So now we're gonna redraw our picture. But what do we want? The answer we want is between here and there. That's our problem. That's our problem. So the answer we want is between there and there. We know this is a right angle. We know that that angle is irrelevant. We have that guy. we have this right angle. It would be nice to know that. Is there any way we can get that? Okay, this angle, no, not that angle. I know this side, I know that. Okay, here we go. I got it. It's there. I just didn't see it. All right, so I know this side, I know that side, and I know that angle. Okay, this side's the green guy, the other side is the purple guy, and the angle is 7.4 degrees. I don't know this length. Do I know that length? Yes, I do. 19.7. I certainly do. It's given. So this side is 19.7, and the green side is 34.8. And I got 2 points. How did I get 2 points? And now I want to find the answer. A and S, answer. So answer, using the law of cosines, the square root of 19.7 squared plus 34.8 squared minus 2. Did I put a 2 in the other guy? 1.7, 34.8 cosine 7.4 degrees. All right, now I'm ready. Second function, square root 19.7 squared plus 34.8 squared minus 2 times 19.7 times 34.8 times cosine 7.4 close parentheses equals. So it's going to be 15.8 meters, miles, 15.8 miles. Now I need an angle. So what is that angle sitting there? And so I'm going to use the law of cosines and say that 15.8 sine 7.4 is equal to sine 19.7 sine A. And that would give me that answer. There's A right there. Okay, so A arc sine 19.7 divided by 15.8 sine 7.4. Oh, I know it is. I agree completely. I get 9.2 degrees. Anybody else get 9.2 degrees? Okay, 9.2 degrees. So 9.2 degrees means I'm coming around this way, and that'd be 171.8, right? Final answer. Final answer. 15.8 miles at 178, 171, 170, 170.8, 170.8. Now, does that seem anywhere near correct? No, it doesn't. It does. that doesn't, I mean, that doesn't even pass the idiot test. I mean, my picture is lousy, I know, but that doesn't even pass the idiot test. All right,
Guess we
so
gotta start over.
no, we're not going to start over. We're gonna take our calculator. It's already in
Oh, yeah.
rectangular mode, right?
Oh, yeah.
And we're gonna put in 15.3 second function. Yeah, second function complex angle 135 plus 24.5 second function complex angle 75 plus 19.7. Oh, I know the problem.
Uh-oh.
I know the problem. Which direction is 180?
180.
So this guy that I'd come and due south is supposed to be going that way. So I know the problem.
Should have thought that.
Hey, right here, this 270. There, now I solved the right problem.
Yeah, come on.
Come on, front row, you're supposed to help me out here. Second function, complex, angle 180. And then I'm going to hit the enter button. I'm going to write my answer down. So that's my plan. 15.3. Second function complex, angle 135. Plus 24.5. Second function complex, angle 75. Plus 19.7. Second function complex, angle 180. Enter. And so my final answer should have been, if I would have done the problem right, 42.1 miles at an angle of 125 degrees.
That's what I got.
It is?
Yeah.
Miracle of miracles. Now, if I go back up, erase everything, I could probably get there from here.
I believe it.
Final answer.
But yeah, it's pretty bad.
Go ahead and do
Okay.
this again.
Now we're going to do it again.
Oh,
Okay, so now we're going to do section 11.7. This time we're going to do it right. We're going to find the x components, we're going to find the y components, and then we're going to add them together, and then we're going to write down our answer.
that sounds like
Okay.
it.
So that's much better. Yeah, so number 2.
Okay.
I can't do number 2 because I'm not on the right page. All right, number 2. All right, so I've got V, and my x component is 27.9 cosine 138. And my y component is 27.9 sine 138. Same 138 as before. And my and what am I? Oh, I'm supposed to put it in standard position. Oh, well, there, I got him there. It's in standard position. But I need my x and y components. So 27.9 times cosine 138. So that's going to be minus 20.7, 27.9 times sine 138. We'll call it 18.7. Okay, so I did number 2, big deal. We'll do number 12. Number 12. No, it was pathetically too easy that you really shouldn't want to look at it anymore. And I could have put my calculator in rectangular mode and then just put in a polar quantity. I could have. Want me to do that too while we're at it? So I'm gonna put my calculator in A plus BI mode. Okay, so I'll go mode, not the real one, but the A plus BI. Okay, so now I'm in A plus BI mode, second function quit, and I'm gonna put in 27.9, second function complex, angle 135, enter, and the calculator says I am minus 20.7 plus 18.7 I, and then I recognize that as the x component is minus 20.7 and the y component is 18.7. And my calculator did it without ever putting in a sine or a cosine. So I can do that. What?
Nothing. Go.
No.
We're good.
You keeping up? You keeping up? The whole point is to not keep up.
We're doing it.
All right, you're keeping up. Something's wrong with the front row guys. They're keeping up.
That's weird.
Now, Raimundo's got a dumbass calculator. I'm sure it can't do this. Okay,
I'm sure it can.
I'm sure it can't do it. Right. Without the 700 pages of instructions that go with it, I'm sure it's totally useless on this type of problem. Yeah, I can imagine. Yeah. All right. So now we're doing number 12.
What?
So Vx
What the hell was the other
is 427. And I already did it twice.
No,
And Vy is 381. And this is miles per hour, miles per hour, miles per hour. So I could go and say the resultant vector is, the magnitude is going to be 427 squared plus 381 squared. And I could say the angle is going to be the arctangent of the absolute value of the y component, 381 divided by 427. And this is a reference angle, but I recognize that I am in the first quadrant, so my reference angle is my answer. So that's what I'm going to do first. Square root 427 squared plus 381 squared equals. And I'm going to have this guy's 572 miles per hour. And then I'm going to go arctangent 381 divided by 427, and I'm going to get my angle is 41.7 degrees. So I have a final answer 572 angle 41.7 degrees. But my calculator is already in rectangular mode, right? It's already in rectangular mode, so I'm going to put it in polar mode. Mode, polar. Okay, so now I'm in polar mode, and now I'm going to go back, and I'm going to enter 427 plus 381i. I'm going to hit the enter button, and I'm going to put down the right answer. So I put in the calculator, I'm in polar mode. I'm going to put 427 plus 381i, and the calculator tells me the answer is 572 angle 41.7 degrees. Okay? So that's what my calculator, oh, look at this. We can do 14. Won't that be much more fun? 14. A series circuit has a resistor. Okay, so there's my resistor, 85 ohms. And it has an inductive reactance. So here's my inductor. And it has an inductor reactance of 45 ohms. And I want to find the impedance and the phase angle. So I want to find the impedance. The impedance will be the square root of 85 squared plus 45 squared. And the phase angle will be the arctangent of the y component, which is 45, over the the x component, which is 85. Now, how do I know that? Well, because if I draw an xy plane, resistance, which is futile in case anybody was wondering, is sitting here on the real axis, and my inductive impedance is in the plus imaginary direction. Okay, so that's in the y direction. So plus I would be my inductive impedance. But everybody in the front row already knows that because they covered that in circuit analysis 1.
Yes.
All right, now, on the other hand, my calculator is in polar mode, right? So yeah, I'm in polar mode, so all I have to do is put 85 plus 45i, and then that'll just skip all the other calculations. I trust you guys put the other numbers in your calculator already. And I'll put down a final answer of 96.1 ohms at an angle of 27.9 degrees. So there's my impedance, 96.1 ohms, by phase angle 27.9 degrees. We'd expect that because the resistance is bigger than the inductive reactance, so we'd expect a smaller angle than 45, right?
Can you play that a little bit?
Yeah. That good enough? Really? No, I shouldn't have to slide down. You should remember this from last semester. Actually, it was a whole year ago. All right.
What? Yeah. Oh yeah, I remember this.
All right, so we'll do 16 next. 16. A series circuit contains a resistor and a capacitor. And a capacitor, and has an impedance of 110. So my impedance is 110. Somebody didn't write 110. Was that you, Raimundo? Didn't put that down. 110. So my impedance is 110. We want to and my phase angle is 49 degrees. And I want to find the reactive, the resistance, and the capacitive reactance. Okay, so my resistance, impedance, cosine, phase angle. My capacitive reactance, impedance, sine, phase angle. All right. So we're all set with that? 110 times cosine 49. So my resistance, 72.2 ohms. My reactive capacitance, 110 times sine 49. 83 ohms. 83.0. 83. I don't know. You put it in yourself. So the impedance, which is 110, would best be the square root of 72.2 squared plus 83 squared. If it's not, then we're hosed. But I have it on pretty good authority that that's the case. All right, number 28. And moving on. Am I okay? Can I move on? Right. What? Number 28. A ship travels 75 miles on some course. I'm here, I'm there, I go 75 miles. 35 degrees. Okay? 35 degrees west of north. 35 degrees west of north? What a bummer. All right, so I got something that looks like that. North, south, east, west. Okay, so now I'm going to go 35 degrees west of north. Okay, so that'd be sort of like this. Okay, so this is 35 and degrees, and this is 75 miles. Okay, now, then it travels 45 miles on a course of 60 degrees south of west. Okay, so 60 degrees south of west would be like that. This is 60 degrees, and it's going 45 miles. Okay, and we want to know the displacement from there to there. That's what we want to know. Oh well. Now what am I in? I'm in polar mode. Yeah, I'm in polar mode on my calculator. I'm pretty sure mode. Yeah, I'm in polar mode on my calculator. So I'm just going to put in. I'm going to calculate what these guys are. So this 35 degrees is really 125 degrees, right? And this 60 degrees is really 240 degrees. Okay, and then I'm just going to put in my calculator 75 angle 125 plus 45 angle 240, and my calculator is just going to give me the answer. Okay, so that's my plan. 75 second function complex angle 125 plus 45 second function complex angle 240, enter, 69.3 at an angle of 161 degrees. Now, because we started with an east to west and south of north thingy, we have to put it in that type of notation for our final answer. So our final answer would be 69.3 degrees at 19 degrees north of west. So right there is 180, and that'd be west. And so this guy here would be that guy there, and that'd be 19 degrees north of west. That's what we would do. Okay, perfectly clear? Now, I don't have a calculator that does it. What am I going to do?
You've got a brain that does it, right?
Okay, so I failed to get the calculator from my cousin. No, I'm on a different page already. So I failed to get a calculator that does it automatic for me, and now I'm sitting here on the test. I left it in my locker in 8th grade, and so I got a problem. So problem 28. Okay, so I got 75 miles, 35 west of north, and I got
You doing 28 again?
yeah, I'm doing it without my calculators. I'm doing it with a $5 calculator. South of west, 60 south of west. Okay, so I recognize this as 75 at an angle of 125. And I recognize this other guy as 45 angle 240. And then I ask myself X and Y components. So I want 75 cosine 125, 75 sine 125. I want 45 cosine 240. I want 45 sine 240. And then I put in my calculator 75 cosine 125. minus 43. 75 sine 125. 61. 45 cosine 240. Minus 22.5. 45 sine 240. Minus 39. Now I'm going to add them together. So my resultant is going to be minus 65.5 for the x guy, and the y guy is going to be 22. So my resultant is going to be the magnitude of the resultant square root of minus 65.5 squared plus 22 squared, which is going to equal 69. And then I want an angle. The angle is going to be a reference angle in the first quadrant. It's going to be the arctangent of the absolute value of the y component divided by the x component. Uh, 18.6 degrees. Okay. And then I'm going to say, well, final answer. Well, I have to figure out what quadrant I'm in. So I'm in the second quadrant. So if I'm the second quadrant, my angle is 180 minus the reference angle. So my angle is going to be 161.4. Is that what it's going to be? All right, so final answer 69 at 19 degrees north of west. Is that what I had before?
Yep.
All right. So I can spend the $20 and have a calculator that just does it for me, or I can have a $5 calculator that just does sines and cosines, and that'll work just as well. Okay, 11.8.
Got a chicken?
11.8. Now, the issue is you have homework that's due, so clearly on Wednesday we're going to do a review for the test. That would be a good time to ask me to work some homework problems that are too difficult for you to do, right? Which would be like all of them?
Yes.
Yeah, pretty much, yeah. So we won't have time to do that, so you'll have to go and figure out what you want to do. Okay, there we go. Number 34. Okay, number 30. Yeah, I think I have enough time to do number 34, don't I?
Let's call it, Doug.
All right, so here's number 34.
An appointment with VA.
Well, you can go anytime you want. So I got this sign. I got A over here. These are the same angles. And I got this sign, Maria's Computer Service, sitting there. And the sign weighs 102.50 pounds. Hangs on two cables of equal length. If each cable can withstand a maximum tension of 825 pounds, at what angles are they unsafe? Okay, so my tension max 825. Tension max
What's the MCS?
8 Maria Computer Services. Can't you? Where were you anyway? I just said that. All right. So at some point, the sign is going to not be able to hold up. Okay, so we're going to redraw the picture.
What?
So here's my picture A. Here's my 8, 2, 5 sitting there. And what's the tension on the guy coming down that isn't there? 6, 2, 5. I got half of the weight is supported by this cable, the other half by that cable. So now I want to know what A is. So A is going to be, that looks like a sine function, right? The sine of the arc sine of the 6, 2, 5 over 8, 2, 2.
8, 2, 5.
6, 2, 5 over 8, 8, 2, 5?
Yeah.
8, 2, 5. That's a 5, this is a 5, this is a 5. Oh, gotcha. Okay. Arc sine, oh, my calculator's off. Who turned it off? The arc sine, 625 divided by 825. 49.25 degrees. 49.25 degrees. Now, what does the question ask? How many significant digits do we have? Not as many as I'm keeping, right? So I can't keep all of those. At what angles are the cables unsafe? Okay, now, if that angle's bigger, will it still be safe?
No.
Okay, so if I was at something like that, would that be okay?
Well, that's the same angle that you drove earlier. It's
So I would.
that-
So this would be.
That would be A.
That would be. So A is where? A is here. That's A. This is a right angle. So if the two cables are just hung like that, would that be safe?
Yes.
Okay. So we want this angle to be smaller, not bigger, because right now that angle's at 90 degrees, and that's safe. So any angle between 90 degrees and 49.25 degrees is going to be a safe angle. But when the angle gets narrower, like this, that's when I'm going to be unsafe. Because now this component is going to be too much, and it's going to make that guy be more. That guy's going to be bigger, because this guy still has to be 2, 6, 5. This guy's going to be a bigger angle, bigger number. All right, so to quote a famous American, we'll go with 50 degrees. 50 degrees is unsafe. Or less. And that way we don't run into a significant digit problem. We wouldn't want to say 49.26 because we don't have that many significant digits. So just add one to the. Am I going the wrong way? I'm going the wrong way. We'll make it 49. I just said it was okay to be higher, right?
Yeah.
49. So 49 is unsafe or less. And this is exactly what you're doing in your physics class sometime next week. So you'll have a similar sign problem. Okay, questions? We're done with up to chapter 11 now. All we have to do is review and a chapter test, and then we can move on.